Hey, fifth grade. So in this lesson, lesson 19, unit 8, we're going to be talking about how to solve problems using fractions and decimal fractions by multiplying using visual models and write an equation. So I would think about it for today. It says Jenna has 1 8/10 pounds of chicken to make skewers with. Each skewer will hold 1/5 of the chicken. How many pounds of chicken are on each skewer? So if we notice, 1 8/10 is written in a decimal fraction, whereas the 1/5 is written in the regular fractions that we see daily. So part A asks us to create a model or diagram to represent the problem. Just like we do in class, we are going to do a rough sketch of our model. This is my model. My total that I have is 1 8/10 pounds. We know that each skewer holds 1/5 of the chicken, so I'm going to break my bar model into 5 to accommodate for my denominator. So here we go, 1, 2, 3, 4, 5. So I'll break my bar model into 5 parts. One part of this bar model will represent the 1/5 of chicken for each skewer. Just that simple. When it asks us to draw a model to represent the problem, we use our model to represent all of the information given to us on a problem. Part B asks us to write a multiplication expression or equation to represent the problem and solve. So our key word here is multiplication. It is capitalized for you, so we know that we are multiplying. There are 2 ways that we can do this. One, we know that we're looking for 1/5 of 1 8/10. Of, as always, represents multiplication. So in this case, we have 1/5 times 1 8/10. In lesson 18, we learned that we need to either make this a decimal fraction so that we can multiply, or 2, make our 1 8/10 a fraction so that we can easily multiply. I'm going to show it in both ways. So my way number 1, I'm going to use simply just all fractions. So if I'm using all fractions, of course, I do not have to change my 1/5. So I have 1/5 times. I need to change my 1 8/10. So I have 1/5 times 1. My 8/10 becomes my fraction, 8/10. In our previous lessons, we learned that in order to multiply a mixed number in a fraction, we need to convert our mixed number into an improper fraction. So here we go. We have 1/5 times, to convert a mixed number into an improper fraction, we're going to do whole number times denominator. So 10 times 1 is 10, plus the numerator. So 10 plus 8 give us 18. My denominator stays the same. So I have 1/5 times 18/10, which gives me 18 over 50. We know that 18 over 50 is not in its simplest form, so we can simplify. We are going to start first by simplifying by 2. So what we do to the bottom, we're going to do to the top. So 18 divided by 2 is 9. 50 divided by 2 is 25. So 9/25 is our simplest form. That is way number 1 that we're going to look at. Let's look at way number 2. Way number 2, we're going to use decimal fractions. So just like in way number 1, I only change one of my numbers in this way also. So we're going to change our 1/5. This may be a little tricky for some of us, but we know that 1/5 is equivalent to 2/10. Remember, we want to get a denominator of 10 or 100 or thousands to represent our 10th place, our 100th place, or our 1000th place. So in this case, we are going to have 2/10 times 1 8/10. In our previous lessons, we worked on multiplying decimals. So we'll do the same here using our standard algorithm. There's 1 digit behind our decimal point, so we have 1 here. There's 1 digit behind our decimal point in 1 8/10, so we have 1 here. At the end, we know we need to move our decimal point 2 places. So here we go. Let's multiply. I'm just going to simply do the multiplication for the sake of time. On your paper, you are going to work out the multiplication yourself. 6 plus 0 is 6. 2 plus 1 is 3. 0 plus 0 is 0. As always, at the end, we need to go back and account for our decimal places. So we need to move our decimal 2 times. 1, 2. This answer gives us 36 hundredths. So a lot of us may be wondering, is 9/25 equivalent to 36 hundredths? We are going to simply prove that. The problem did not ask us to prove, but we are going to prove it because we need to know that regardless if we're doing it fractions or decimal fractions, we're getting the same answer. So here we go, proving it. We can simply change our fraction into a equivalent fraction with the denominator of 100 so that we can account for our hundredths place. So 25 times 4 gives us 100. 9 times 4 gives us 36. So we have 36 over 100. We know that 36 over 100 in decimal fraction form is 36 hundredths. This is the same answer that we got in way number 2 when we did our decimal fractions. So yes, our answer did lead us to the same answer. In this packet for today, you will be converting either back to fractions or to decimal fractions. So our key point for today, for this lesson, is we can write numbers in different forms to solve problems. I'll post the key point along with this lesson, but our key point is we can rewrite numbers in different forms to solve problems. So now we have our interact with the material. Above the interact with the material, I did repost our key point for today. Our interact with the material reads, Andres complete a 5-kilometer race in 13 and 5/10 minutes. His sister's time was 1.5 times longer than his time. How long in minutes did it take his sister to run a race? So as always, we are going to use our cube method to annotate our problem. Make sure you're boxing the questions. First things first, we are going to write our goal. In this problem is asking us to find how long it takes his sister to complete the race. The things that we know. So let's talk about the things that we know. We know that the total race is 5 kilometers long. We know that Andres took 13 and 5/10 minutes. We also know that his sister took 1.5 times longer. So as we practice in class, this 1.5 times longer indicates to us that we are multiplying. So if we were to show the things that we know in the model, I'll simply just draw my little race saying that Andres took 13 and 5/10 minutes, and his sister took 1.5 times longer. So we know she took the 13 and 5/10 minutes, but we need to figure out what the 1.5 times longer will be. So here we go. Let's talk about our equation, our multiplication equation. We know that we have 13 and 5/10 minutes times the 1.5 times longer that it took the sister. As mentioned in the think about it, here we have a decimal fraction. And here we have our mixed number or our regular fraction. We want to make sure that we are getting both of these in one unit, whether it's decimal fractions or fraction, in order for us to solve. So similar to the thing about it, I'm going to do it in both ways just so that I can prove for all students, regardless of which way you're doing it, how this works. So first things first, we are going to do our decimal fraction. We are going to solve using our decimal fraction. I'm going to simply rewrite my expression, 13 5/10 times, we have 1.5. So we know that 5/10 represent a half. So I have 13 5/10 times 1 5/10. I'm going to simply use my standard algorithm to multiply. Remember, we are lining up the digits, and we are going to talk about the decimals first, and then before we solve our standard algorithm. So there is one digit after our decimal in our 13 5/10, and one digit after our decimal in our 1 5/10, which tells me that at the end of my standard algorithm, I need to move a total of 2 places. So as always, I'm going to go through the multiplication by myself. At home, I encourage you to do the multiplication yourself so that you can see. These 2 places tell me at the end I need to move my 2 decimals. My answer becomes 20 and 25 hundredths minutes. That's my answer in my decimal fraction form. We are now going to look at way number 2, which is our fraction form in this problem, in this case. So 13 5/10 we are simply going to rewrite as a fraction. In our 1 1/2, it's already a fraction. We know that if we have a mixed number times a mixed number, we need to convert them to improper fractions before multiplying. So 13 times 10 is 130, times plus 5, is 135 over 10, times 2 times 1 is 2, plus 1 is 3, 135 tenths times 3 halves. We are going to multiply our numerator times our numerator over our denominator times our denominator. So here we go, 135 times 3. 5 times 3 is 15. 3 times 3 is 9, plus 1 is 10. 3 times 1 is 3, plus 1 is 4. So we have 405 over 10 times 2 is 20. So we have 405 over 20. We do now end up with a improper fraction of 405 over 20. We're just going to simply turn that into a mixed number. I'm going to break off my work so that you guys can see. We know that 20 could go into 405 20 times. 20 times 20 is 400, giving us 5 over 20 left. 5 over 20 is not in its simplest form. We can divide them both by 5, giving us 20 and 1/4. We know that 20 and 1/4 is equivalent to 20 and 25 hundredths minutes. Let me prove to you guys how that is true. So just like before, I'm just going to simply prove how 20 and 1/4 is equivalent to 20 and 25 hundredths. So 20 and 1/4 we can change to a fraction with a denominator of 100. So we know that 4 times 25 is 100. So 1 times 25 is 25. So I'm going to get 20 and 25 over 100. If I change that back into a decimal, I'm going to get 20 and 2500 minutes. So this concludes that it will take his sister. It will take his sister 20 and 2500 minutes to complete the race. All right, so in this lesson, our key takeaway is that we always need to convert to one form. So we're either always going to convert to decimal fractions or we're going to convert to fractions.